right, good morning, everybody. Today is Wednesday, May 4th, 2016, and this is Before the First Cup with Jules here on UCY.TV. Happy Wednesday, everybody. It is 53 degrees and sunny here in upstate New York, and feels like spring has sprung. I know my nose knows because I'm kind of dying. Well, where do we leave off on Friday? I don't know. We're going to see. This is like the fourth freaking reboot of my machine in the last 3 days. And I am talking like all these machines. I don't know what's going on, but I think I've been put on the list for forcing Windows 10 upgrades. So let's make everything break on every computer your own. We titled the show Life 2.0 creates sperm, egg, and mini brain balls from skin cells. And we talked about some pretty insane stuff. We discovered that they are now utilizing skin cells that they coax into any cell just about within the human body, able to turn them into the pluripotent version of those cells that takes them back to an embryonic state, and then allows them to turn it into the cell that they need and then inject it into the body for repair. We looked at egg. They're creating egg. They're creating sperm. They're creating heart and lung, we read about. They're also creating, this was one we didn't talk about, and I thought was pretty interesting, blood stem cells. And I was like, how is this different? But it's actual stem cells to make blood. And they're talking about using it as a treatment for leukemia, I believe. Let's read about this one really quick. Researchers at McMaster's University Stem Cell and Cancer Research Institute have made significant steps forward in understanding the stem cells of human blood after discovering how a key protein allows for better control and regeneration of these cells. This discovery, published today in the Scientific Journal of Nature, illustrates how a protein called Musashi2 regulates the function and development of important blood stem cells. This knowledge provides new strategies that can be used to control the growth of these cells that can be used as therapeutics for a range of life-threatening diseases, but are in general in very short supply. The senior author of this paper is Kristen Hope. Okay. It involves collaborators from the University of California, San Diego, University of Toronto, and University of Montreal. And Hope says that the discovery could be impactful for tens of thousands of patients suffering from a range of blood-based disorders, including leukemia, lymphoma, aplastic anemia, sickle cell disease, and more. Ding, ding. So there you go. Interesting that they are finding ways to fix all of these stem cells, use stem cells to fix all of these problems. I mean, really, when you start thinking about it, this could very possibly put biopharma out of business if they find a way to have the body fix itself, right? We can't have that shit. It's not going to work out too well for the tech investors that are investing in all this precision medicine. Of course, it's all about designer medicine. I saw a story last night I was reading about this one drug, and I closed it already because it was in Chrome, and Chrome is totally broken. So is Internet Explorer, and I don't know, it wasn't working for like 4 days, and then all of a sudden, bloop, it's back to normal. But now Chrome works not at all on any machine, so I have had to kill it. But what was I saying? Oh, I was reading the story about this one drug. I don't even remember what it was called. It started with a G. And they developed it for this rare blood disorder that, like, talk about you forgot to go to business school. If you're going to be in a lab and you're going to be developing something, I mean, this is the way Big Pharma works now. You're going to want to develop a drug that you're going to have consumers for, right? So you can at least make back the money that it cost you to do the research and development. They developed this drug that maybe 100 people have this disease, and out of those 100 people that have the disease, only one person could pay for it. And the treatment, and actually they didn't even end up paying for it. The insurance company did end up paying for it. But the treatment itself, and I don't even remember what it was. It was some blood or something disorder. They were shooting this person up, trying to fix him. Oh no! Hold on. It was late. It was a DNA, a genetic. I don't remember it was some weird disease, but what they had done is they used viruses, like we had talked about, or they sucked the guts out of the viruses, and they put whatever gene sequence they had used, CRISPR, whatever gene sequence they wanted to repair, and it was a genetic disease within this woman, and her blood had a problem producing lipase. That's what it was, and it was a very rare genetic disorder. So when you drew blood, when you draw blood from a person with this genetic disorder, instead of the blood being red, it's actually like a cream color, I guess. That's what she said. It sounded really disgusting. And it prevents the blood and the red blood cells from properly holding, like, I don't know if it was proteins. It must be, because lipase is a protein. So what did they do? They edited some DNA, put it into these viruses, shot it up into her. It went in, and it actually physically freaking rewrote her DNA strands. So now her blood's normal and she lives normal, and they cured her, they said. But here's the thing, and we talked about this in the very beginning, like right now, we are the guinea pigs in the petri dish, okay? And like I said, when you go and you're dying and desperate, and they say, well, we have I keep wanting to call them case studies, is pretty much what it is, but we have I'm sorry, guys. I'm having a really rough time this week. We have you know what I mean. I don't even know what I mean. We have I can't remember what it's called, where they do studies. Whatever. You step up and you say, please take me. I have no other choice. I'm dying, and I want to do whatever the newest, best, and greatest is. They do that for free because you're part of a study. And this drug I was reading about yesterday, yeah, they've given it away a whole bunch of times, and they've charged for it once commercially, which means it's not going to be a very commercially viable product, because they had to beg the insurance company to give them the $1 million, yes, $1 million that it costs for that new treatment. So regardless, precision medicine, like I said, is not for you and me. It's for the rich people. I really don't see how supply and demand is going to cover anything here. I mean, what I think they're doing is they're sucking all the public coffers right now, sprinkling DARPA and National Institute of Health funding from all over at these universities, and spinning out their own little corporations, right? They have a little IPO and bring the best and the brightest out of some of their other institutions and put them in charge. And now they have another little new biopharma engine to start pumping out research as well as product. So when the day comes when this medicine is not for you and me, and it becomes painfully apparent, they'll already have all their cures in place. And, then the 100 billionaires or 500 billionaires, how many ever there are, I'm sure there's a few between the millionaires and the billionaires. There's a few. That might be enough to at least make them some profit, so each of them can go on and live forever and still have enough money to do what they want to do. All right, back to this blood stem cells. So, right, the cord blood, umbilical cord blood is actually where I had first heard about blood stem cells. And I remember when I had my daughter, I had already looked into cord blood. I had found a place that stored it, and it really wasn't that much. It was like $3 a month or something to store the cord blood. And I was like, well, I mean, not that you want a monthly payment, but $3 a month really isn't that much. And cord blood, the promise of cord blood in the future was that if your child ever got sick, that they literally could create any cures for them out of that cord blood. So I was already, when I gave birth, for them to save the cord blood and the placenta. I think they save the whole thing and they send it for storage. Do you know those ass wipes in the hospital? They had me so drugged up, first of all. They had me like signing shit while I was under the influence. And I mean, literally, I was in there for 9 days. I was in intensive care. I was in pretty bad shape. I had wires and freaking pipes hanging out of all my arms, out of both of them. And I didn't know which way was up. I honestly didn't. And they had me signing papers and stuff, signing this, signing that. Like I had any clue what they were even talking to me about, let alone signing, as I'm in labor all these days too, to boot. But one of the things that they convinced me of, apparently, during that whole time, is that storing cord blood was a scam. And they had me ink a paper to say that I wasn't storing my cord blood, and they take it. They take it for free. And this is any hospital. Now think about this. Cord blood is where you're getting the infant newborn stem cells, which are the most powerful stem cells in the human body. And we're giving that shit away for free for every child that is born. Think about the massive store that could give some elite agency of infant cord blood that doesn't belong to anybody. Think about that. For free, no less. Honestly, if the insurance company paid for the birth, if I were the insurance company, I'd be demanding the freaking cord blood from that newborn to be able to put in a bank and then sell back to the mad science mad companies. I mean, isn't that not crazy? Like, where's all this cord blood? So let's read about cord blood. This is in the story about these blood stem cells. It says we've really shown a light on the way these stem cells work, and we now understand that they operate at a completely new level, and that provides us with a serious advantage in determining how to maximize these stem cells in therapeutics. With this newfound ability to control over the regeneration of these cells, more people will be able to get the treatment that they need. The research team specifically looked at stem cells from the umbilical cord blood, a proven but underutilized source of stem cells for the treatment of adult blood cancers. And these stem cells have the potential to become an important therapeutic for thousands of people suffering from blood cancers who are awaiting life-saving transplants. I remember one of the things I had read about is that if you saved your child's cord blood, there was a very good chance that if you ever ended up with leukemia or something, that their cord blood might actually be able to be used to save you as well. And I can't, honestly, looking back now on that hospital, they had me do a lot of stuff that they shouldn't have done. And having me sign legal papers, and I walked in there saying I wanted to store the cord blood, and they waited until I was drugged up and convinced me to sign the paper so they could take it. I think they robbed me, honestly, because I had been, you guys know, you've listened to me long enough. I've been doing this stuff a long time, but this is anything like this I dig into, especially if it affects me directly. You're having a baby, you better start reading about, all the little bits and pieces. And cord blood was one of those things that even though that many years ago they weren't doing this, and we're only talking 10 years ago, it already was stuff they were experimenting with in the lab. And stem cells have been an issue since the 80s. We talked about that with Christopher Reeve and Reagan and whatever. There was the big argument about all that. But it's not like they haven't been doing research globally on this for 20, 30 years. So anyway, it just pisses me off that hospital, and they probably took it. They probably put it in a lab. And who knows what they're using it for? They have your baby's blood. They could be using it to clone. They could be using it to create egg and sperm cells now, for God's sakes. And we just talked about that. Heart cells, brain cells, lung cells. I can't even believe. Think about how much money, if you owned that placenta and the cord with the cord blood, how much money that would be worth. Think about all the poor people that are popping out kids that, I don't know, even though they're giving up the placenta and the umbilical cord, you've always been giving that up and it didn't cost anything. How about you kick back people $1,000 for the leftover parts, because you're going to use them to make some drug cocktails, because that's exactly what they're going to do with it. I'll guarantee you they don't throw that stuff out. I know they don't. They know how important this is. The research team specifically looked at cells from umbilical cord blood, a proven but underutilized source of stem cells for the treatment of adult blood cancers. Cells from the umbilical cord blood have unique properties that make them easier for use in transplantation, including accessibility and adaptability, and as a result, they are safer and more effective transplants. The problem, the scientist points out, is that there are very few stem cells available in individual cord blood. Only about 5% of all the samples actually contain enough cells for transplants. So, okay, ding, ding, but hey, we have petri dishes, right? Can't we grow more? I would have to say probably. The team's research into the importance of MUASHI-2 and its role in expanding the number of stem cells in a given cord blood sample could help ease the current stem cell shortages. So there you go. They're working on something called MUASHI-2 that allows them to expand the number of stem cells in a cord blood sample. I mean, look, guys, there is nothing that I've run across now, and let's just say in the last year, but I mean, we could probably go way further back than that, but let's just say, just for argument's sake, in the last year, there is not much that I can imagine, happy or dystopic, that we don't have the technological ability to figure out how to do. Like I said on Friday, your imagination is what is limiting us, and it's been that way for quite a long time. But now we can make that a reality. And all this mad science pretty much can become a reality if we wanted it to. All right, Jean Yeo, associate professor at the University of California, San Diego, corresponding author of the study, adds most stem cells focus on proteins that bind DNA to control gene output. And the prominent role we found for MUASHI-2, a protein that instead binds RNA, also underscores the urgency to study the second layer of gene regulation in stem cells. Providing enhanced numbers of stem cells for transplantation could alleviate some of the current post-transplantation complications and allow for faster recoveries, in turn reducing overall healthcare costs and wait times for newly diagnosed patients seeking treatment. I mean, guys, at some point in the future with stem cells, and honestly, I don't know how this is going to play out with biopharma and pharmaceuticals. I think pharmaceuticals are going to become a thing of the past. It's between stem cells and nanobots, and we're going to look at some of these new nano machines that they're working on. It's pretty scary, but they'll be able to fix and do anything. There will not be drugs anymore that go in and influence you, at least not like the way we do it today. We're literally in the caveman medicine period still now. All right, so we looked also last week at a stem cell treatment that uses your love handles. Yeah, your fat cells. Fat cells could repair any tissue in the body, and human trials are already expected in 2017. Firefox is now also doing the same thing. Flash is just crashing left and right. This is really pissing me off. This is like the fourth time. I'm going to tell you, Monday, everything was lined up. I lost the whole machine. Tuesday, I fell out the back door. My finger is so bent and swollen, and I had ice on it yesterday. Spilled coffee. The freaking screen door fell out and hit me in the head. Wasn't even funny. And today, I stayed up late last night. I rebooted again this machine. I had everything then stored to a little text file, and I started rebuilding the show I was going to do today. I wake up this morning and not a thing done since I went to bed, and it's all having issues again. It's just, it's more energy than I have right now, suffering from mega freaking pollen allergies. All right, in a world's first, Australian scientists have figured out how to reprogram adult bone or fat cells to form stem cells that could permanently regenerate any damaged tissue in the body. Researchers were inspired by the way salamanders, I loved salamanders, are so cute. We had two when I was growing up, are able to replace their lost limbs, and developed a technique that gives adult cells the ability to lose their adult characteristics, then multiply and regenerate as multiple cell types, what is known as multipotency. That means that the new stem cells can hypothetically repair any injury in the body, from severe spinal cords to joint and muscle degeneration. And it's a pretty big deal because there are currently no adult stem cells that naturally regenerate multiple types of tissues. Now, guys, I talk about Mad Science Gone Mad quite often, as you would know. And out of any of the technologies out there, stem cells, honestly, if I were dying and desperate, I would be looking at some sort of studies that I could participate in where they utilized some stem cell technology, because I don't want nanobots, self-replicating, self-thinking, remote-controlled shit in my blood. But if you could create me some stem cells out of my own skin or out of my love handles that then would go in and fix anything that was wrong with me, I'd be all down for that. This, honestly, this technology, we talked about this last week, back in the 80s, they were all crying over using aborted fetal tissue. And so research here was all stopped, but it wasn't stopped around the rest of the world, just here because of our, ethics that we have in this country that, are completely out of window. I think we were just pretending back at that point it was one particular person's ethics, which, like I said, how ironic that he died of degenerative brain disease that probably could have been cured by stem cell therapy. But regardless, we've gotten beyond that issue now because we no longer have to use aborted fetal stem cells. We can use our own stem cells and our own fat tissue to create stem cells. And I'd be very interested to know how expensive this is, because that is one thing that I don't see a lot mentioned. I'm all twisted here. A lot mentioned in the articles about stem cells. There's nobody crying about how damn expensive it is, if you notice. Unlike the precision medicine DNA CRISPR cure I was reading about yesterday, $1 million of freaking treatment. Like, who would be able to afford that except the most elite? Yeah, great. You can fix a genetic disease that you were born with out of the womb, but it's going to cost you $1 million. But hey, what is a normal life worth to you? The insurance companies aren't going to shell that out, and there's no way the majority of us are ever going to have $1 million in assets that we can afford to give up to fix, Susie's blood disorder. It's just not going to happen. But I really think that stem cells, if they wanted to take things to the next level, the stem cell treatment would be where they were focusing all of their attention, especially if it's cheap, down, and dirty, and they could do it easily. So anyway, it can fix anything from severed spinal cords to joint and muscle degeneration. It's a pretty big deal because there are currently no adult stem cells that naturally regenerate multiple tissue types. This technique is a significant advance on many of the current unproven stem cell therapies, which have shown little or no objective evidence that they contribute directly to new tissue formation, said lead researcher John Pimenda from the University of South Wales. It seems to all be in Australia, man. It's a lizard's pit right now. Australia is bent over and spread them wide for the New World Order. Keep your eye on them, because I'm telling you, every time we turn around, there's something else going on in Australia, and we find out that they got some sort of sprinkle money from the United States. It's like the mad science lab down there. All the things we don't want people to be paying attention to here. But this is good stuff. We are currently assessing whether adult human fat cells reprogrammed into induced multiponent stem cells, which must be better than pluripotent. These are multipotent IMS instead of the IPS, which is what we read about on Friday, cells, can safely repair damaged tissue in mice, with human trials expected to begin in late 2017. And the one thing about the fat cells is that they could be used to regenerate any type of cells in the human body. So I'm sure that's where the multi in multipotent comes from. Right now, although it is an exciting and much hyped field of study, stem cell therapy still has a number of limitations, primarily because the most useful cells are embryonic stem cells, which are taken from developing embryos and have the potential to become any type of cell in the body. Right, but we just said they've come up with ways around that. But they also have a tendency, and that is the embryonic stem cells, to form tumors and cannot be directly transplanted into adult cells. Which, that's something that, if the growth is out of control, that could happen. Instead, researchers are able to use tissue-specific adult cells, which can only turn into cell types in their region of the body. For example, lung stem cells can only differentiate into lung tissue, so they're not as versatile as scientists need, but it means that lung stem cells can be used to repair the lung, and you don't have to worry about them going rogue. Scientists have also worked out how to reprogram regular adult stem cells into induced pluripotent stem cells. That's the one I was talking about, the IPS, a type of stem cell that is even more, it's even more flexible than the multipotent stem cells, but requires the use of viruses in order for the cells to be reset, which isn't ideal to help treat patients. That is why this new research is so exciting. And again, the virus technology, we've talked about that a lot of times. They use viruses as a Trojan horse in a lot of these technologies. We also were seeing in some of the genetic modification that they were doing in food. They had mentioned it in the Arctic tomato, that they used that Arctic flounder DNA and sucked all the guts out of some viruses and shot it in there and then used that to go infect cells. And I don't know, they explain exactly how they did it, but it just seems to me that all of these new technologies, they're using viruses, whether they be biological or synthetic, those are those virus-like particles, as a Trojan horse to then fake the immune system to sneak stuff inside. And viruses are really, really good at breaching cell walls and getting inside and then replicating. So it bothers me that under the guise of a lot of this potentially groundbreaking, life-saving medicine, we're finding the double-edged sword, which is chinks in the armor to be able to create lots of death and destruction as well, right? And you did an infection with some sort of genetically modified virus with a custom payload, then get into the body and infect every cell and mutate it, change it, like that $1 million cure that I was reading about, and go in and change the DNA sequence in every cell. So you could take a genetic disease and quote unquote cure it, but you've infected every cell in a human organism. And that makes me think about like the gene drive. It very much sounded to me like gene drive technology, like they're experimenting with in the genetically modified mosquitoes with Exotech, where population suppression or population elimination, right? Where those were those two ways that they could release a genetic change into the mosquito, into the population. And when they do population elimination, that allows them to eliminate an entire species in one generation. if they infected humans with something like that, that could go in and infect every cell in the body and rewrite your DNA, think about how easy it would be to, you know, I don't know, rewrite something that's quite crucial. Bloop, and everybody just drops dead. I mean, my brain, I I I have that gene or two or 12, genetically speaking, through my family line. I had some not so nice people in my family in my past, and I have that gene, guys. I stand on the line and I look over at the one side and I look at the other. When I was a teenager, I was quite a handful. It took a lot of soul searching for me to get on the right side of things. I was never a trouble kid, but I always wanted to be. I always thought about it. I do a lot of thinking, but see, I think before I act. Well, I was talking about the brain being the last bastion of freedom because it's really saved me. I can work through a lot of things and do the whole moral weight system to decide whether or not the consequences are worth, the reward. And a lot of times they're not. So I tend to stay on the good side of things. But I'm going to tell you, it's coming very helpful in understanding the criminal mind, and not just the criminal mind, but the criminal mind of the elites that are doing all this. And it's been very easy for me to see down timelines where the world isn't so nice and fuzzy, unicorny, rainbowy. And this isn't going to cure the world and make us all healthy and happy like 21st century, 25th Buck Rogers, 25th century healthy white room. Okay, this could be used to enslave and kill and biowarfare us out of existence very easily. When I was listening to that lecture a couple weeks ago from the professor that was very intimately involved in the CRISPR creation, he was a mentor to some of the scientists that had created it. I mentioned this last week. He had said that before CRISPR ever became this promising new technology to be able to unzip DNA and insert DNA sequences that we wanted to replace and then zip them back up again. Before that ever happened, all we knew how to do with CRISPR was to unzip. And CRISPR was a death machine. Okay. So, for every good, there is a bad. For every sword, there's another edge. And it all depends on the hands that these technologies are in. And the unfortunate sad fact of the matter is that even though some of these researchers that are all yapping like little yappy dogs and excited over the stuff, and they should be because it is pretty damn exciting, they're holding it up to the ones who want to be gods, saying, look at what we've discovered how to do, and we're going to give you this technology because you funded it and we love you and we're going to kiss your butts. And they're going to turn around and weaponize it and charge you bazillions of dollars for the ones that can afford it after they guinea pigged it out in the human trials with the desperate and the dying. So anyway, back into the story here. We're in the iPS stem cells. So induced pluripotent stem cells, which is a type of stem cell that's even more flexible than the multipotent stem cells, but requires the use of viruses in order for the cells to be reset, which isn't ideal to help treat patients. That's why this new research is so exciting. Embryonic stem cells cannot be used to treat damaged tissue because of their tumor forming capability. So, that's one thing. Talking about that cord blood, they're saying that those stem cells, they don't know how to control them because they just ramp up producing cells. But I'm telling you, I still think that blood is very important. And I think that at some point in the future, anyone who saved that cord blood is going to have a treasure trove of disease curing capability in the future. If anybody's having a kid, I would suggest doing a quick search online and find somebody that stores cord blood, because I wouldn't be giving that to the hospital. I wouldn't. That's like your own little, and who knows, maybe you could have a DIY cord blood kit for your back bedroom at some point in the future to be able to create your own stem cells. I mean, who knows? I wouldn't doubt it. the way things are going and moving so fast here, but I wouldn't get rid of cord blood. If you have a chance to keep it, don't let them do you like they did me, all drugged up and tied to the beepy machines, shooting you full of drugs and then bringing you the clipboard with the pen saying sign here. No, that's a dumb idea. I mean, honestly, I don't even remember it. It was just such a haze of blur of drug induced sickness. I can't even believe that any of that I signed was legal. Anyway, back to this. Embryonic stem cells cannot be used to treat damaged tissue because of their tumor forming capability. The other problem is when generating stem cells is a requirement to use viruses to transform into stem cells, which is not clinically acceptable, but we believe that with this new technique, we can overcome these issues. These new types of stem cells collected from adult human bone and fat cells are then treated with two compounds. One's called AZA, which is 5-azacitidine, and the second one is PDGF-AB, which is a platelet-derived growth factor AB for 2 days. This kickstarts the process of differentiation, which basically means that it started to revert them to a multipotent stem cell state. The stem cells were then kept for a few weeks in the PDF-GPAB substance while they slowly changed into stem cells, eventually becoming tissue regenerative IMS cells, which basically means that they can repair any tissue in the body. Hey, I even have a little video, but guess what? Skype wouldn't even open on this machine, so we're not going to be able to do that today. This technique is groundbreaking because IMS stem cells regulate multiple tissue types, and we have taken bone and fat cells, switched off their memory, and converted them into stem cells so that they can repair different cell types once they are put back into the body. Right now, this process is only a proof of concept, but researchers are already on their way of furthering the technique, which are currently investigating if human IMS cells can be transformed and repair damaged tissue in mice. And the researchers also want to look into how cells act at the sites of transplantation. And if all goes well, human trials are expected in late 2017. So, all right, let's look a little bit more because I want to get to actually the new stuff for today. So we looked at how they could also create heart cells and brain cells. And this is out of skin cells. They're going to turn them into heart and brain stem cells. We saw, too, there was a story that came out April 14th. Researchers are testing stem cells to treat Alzheimer's in first-of-its-kind trial. Researchers at the University of Miami Miller School of Medicine are using MSC stem cells, mesenchymal. I don't know what these are. I haven't run across these yet. Mesenchymal, mesenchymal, mesenchymal stem cells in an attempt to slow or reverse the symptoms of Alzheimer's. The team is aiming to enroll 30 patients who will be tested and observed for cognitive function, memory, and quality of life and brain volume over the course of a year. This phase 1 study, we want to prove that it is safe, says Bernard Baumel, principal investigator and assistant professor of neurology at the Miller School of Medicine. We minimally would like to see that it slows down the progression of the disease. MCS cells are anti-inflammatory, and they promote indigenous stem cells in your body to proliferate. They stimulate cell growth and have lots of attitudes that are very advantageous for using them in humans. One such attribute is the ability to migrate to areas of the body which are needed. And Baumel explained that if you were to inject stem cells into the body of someone who had no need for them, they would simply wither away and die. However, for patients enrolled in the trial, due to the pathology of Alzheimer's, Baumel and his team hope to see that the MCS would cross that blood-brain barrier, ding, 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 and help reduce inflammation, stimulate neural stem cells to proliferate and repair damaged areas as well. And in a best case scenario, Baumel says, the team would see MCS remove brain inflammation associated with Alzheimer's altogether. This approach has previously been tested in mice with promising results, and researchers pathologically altered the mouse to replicate Alzheimer's, which saw an increase in amyloid plaque buildup and caused them to struggle to move through a maze. The mice treated with the MCS stem cells had a marked reduction in plaques and showed an improvement in their behavior. This is the first time it's being done in humans, Baumel says, and there is no successful study done therapeutically since 2002. So we're really excited that this new approach to Alzheimer's, and we hope that it works. And yeah, guys, like I said, the desperate step right up for your clinical trial. That's what they're called. That hasn't been tested, hasn't been done anywhere before. But hey, it's mad science gone mad. And if you want to be a part of this study because, you have no other choice, then you can go down in history helping us use you as the lab guinea pig rat for all these human trials that before weren't considered quote unquote ethical. We ran into that a long time ago. We started talking about them doing gene editing on embryos and some of this other stuff, and including humans in the research that they were doing, because typically a lot of the stuff is only done in animals. We found out that the FDA is standing in the way, right? We talked about the 21st Century Cures Act, and to get rid of all this pesky regulation and safety testing and assessments before it ever goes to market, because it is keeping life-saving technologies away from me, you, and Nana. And this would be one of these things. I mean, if you see a lot of this stuff is quote-unquote clinical trial, only been tried in mice before, and now, first ever, we're hoping to have clinical trials here in the next year. This is the second or third thing just today we read about. They are pushing this agenda, this medicine. Remember, we talked about the R&D line item budget for a lot of these companies. Used to be millions, if not billions of dollars for researching new products before they went to market and to get that FDA approval. It was millions to get FDA approval on something. And now, with clinical trials, you don't need to do that. Now we can write a case study once you've had successes and then sell it left and right if it doesn't cost millions of dollars and people can actually afford it. We also read about some of the embryo editing that's going on. We had Sweden, China, and the UK that are now editing human embryos, seeing what they can do. Of course, none of them are quote-unquote legally allowed to be transplanted or grown to term, but they are already manipulating human embryos in the beginning stages of life. When sperm meets egg, we discovered they make a flash of light too, by the way, which was just seeing that video. If you haven't seen it, just do a search. It's just kind of set me back there for a second to see that. Well, Chinese fertility doctors, we mentioned this on Friday, have now tried to make HIV-proof humans. It ended in a bust. But this is the second time researchers in China revealed that they made a go at genetically modifying human embryos. They wanted to see whether or not they could protect DNA by installing a gene that protects against the HIV infection in the human DNA strands. But it didn't work yet. The scientists cautioned that they believe making actual genetically modified babies should be strictly prohibited, but perhaps only until the technology is perfected, they said. We believe it is necessary to keep developing and improving the technologies for precise genetic modification in humans, since gene modification could, quote, provide solutions for genetic diseases and improve human health. Yeah, it's all about making things better for you and me. All right, so on Friday, we talked about brain balls. Brain balls. We made brain balls out of skin cells. And then they were also talking back here. Where do we have it? That they had created not only brain cells, but heart cells using skin cells as well. Well, here we go, guys, because it has now taken a step into the bizarro world. I don't know if anyone caught this in the feed, but the story came out yesterday. I posted a couple different versions of this. So we talked Friday about skin cells making little mini thinking versions of your brain in a ball size. Because if you made them like in a brain shape, you couldn't get blood vessels to the center of the brain and they would end up rotting from the inside out, right? We talked about that. So they made them in ball shape because little mini brain balls could get the blood circulation flowing, and they think that they would help aid in research on Zika, autism, and new drugs. And of course, yes, we have the Zika pandemic everywhere. Patients, we also have this dementia outbreak. So brain balls in the future could be very helpful to do lots of things that we could fix with little mini brain balls that we make out of your skin cells. And the first doctor we had read about was actually using himself as the experiment. They were his little brain balls growing in dishes, rolling around. And he said they think. They just don't have any input yet, so there's nothing to think about. But they are thinking living little brain balls. Well, check this out, guys. This is like beyond. I think this is probably one of the most disturbing things ever, 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 ever. Put in a seatbelt. A biotech company has been given permission by an institutional review board in the United States and India to utilize 20, count them 20, clinically dead patients to try to resurrect them from death utilizing brain stem cells. I said it. Yeah. It has taken now a step into the zombie realm of scariness. Frankenstein's monster come back to life. I mean, you know, I was thinking about it. So they got permission to do this. Did they get the permission of those 20 dead people to try to bring them back like Pet Cemetery? I mean, maybe these 20 dead people were donated to science. I don't know. But think about how, not just on a base level horrifying this is, but how ethically disturbing this is. And beyond ethically disturbing, how morally disturbing this is. Now, we know all these tech billionaires, a lot of this mad science is being financed by the tech titans who want to live forever. Check this out. In a controversial move, a U.S. biotechnology company has been given permission to recruit. Yeah, recruit that have no idea what that you're recruiting them for. To recruit 20 clinically dead patients and try to bring their central nervous systems back to life. If they can successfully reanimate parts of the upper spinal cord where the lower brain stem is located, there is a possibility that they could kickstart vital body functions such as breathing and heartbeats, something that these patients can only do with the help of machines. So I guess these people aren't on a cold slab yet. They must be on ventilators. This represents the first trial of its kind and another step toward the eventual reversal of death in our lifetime, says CEO of BioQuark, Ira Pastor. You know, so you want to talk about like the ultimate in desperation. All right, we got a disease and it's terminal. You know, it's only going to be a matter of time. Or you're dead already. Well, it's over by that point. But now you got a loved one who's been living for 25 years in a pretty vegetative state connected to machines, sucking the estate dry. You can't pull the plug. You know, we've seen a couple national debates over that. I don't remember either of their names, but there were a couple over the last maybe 20 years or so. Chicago, I think, was one of them, where these people had been determined to be brain dead. No hope ever for recovery. they've been on the machines, and they had to make the decision to, I don't think they actually pulled the plug on Shivago. They pulled the feeding tube, which is horrific. So they slowly starve to death. I mean, that definitely is a situation that nobody ever wants to find themselves in. You can sign a living will. I don't know if anyone was aware of that, but if you're in the hospital for 9 days in intensive care, they make you sign papers because, you could end up half brain dead. And you want to make sure that those instructions are out there before you're in that state as to whether or not you want to be kept artificially alive on machines forever. And you can sign a piece of paper that says, no, do not resuscitate if that becomes an issue. Well, looks like they're going to try and find a way now to get around that. The BioTech team, which was granted permission from an institutional review board at where? Oh, the National Institute of Health. Yes! Good old NIH is back at it again. In the U.S. and India to begin clinical trials whenever they are ready. Says that it plans to start recruiting patients for its so-called, they're calling it, the ReAnima project immediately. Phase 1 trial is described as a non-randomized proof of concept study to determine whether or not they can reverse brain death by using a combination of techniques including drug administration, nerve stimulation, and laser therapy. This is best case scenario, failing actual reanimation of the central nervous system. The team will be investigating if they can affect any changes in the meninges, meninges, of the brain, layers of tissue that sit between the skull and the surface of the brain. And in particular, the team will be looking for improvements in a patient's pulse, blood oxygen saturation, blood pressure, and respiration. Once they've been granted permission from the families, the researchers will treat the 20 clinically dead patients over a 6-week period in Anupam Hospital in Ranjapur, India. And after this, they will be monitored for several months to see if any changes have occurred. We hope to see results in the first 2 or 3 months, they said. But how exactly does BioTech intend to bring back the dead? Well, they'll be administering 4 types of treatments. One is injecting peptides, which are simple protein chains, into the spinal cord daily. 2 would be injecting stem cells, like the little mini brain ball stem cells, into the brain twice weekly. Number 3 is transcranial laser therapy, a non-invasive treatment that uses light. Yes, we talked about light pulses to the brain to penetrate the skull to activate the body's natural recovery processes, and has been already tested on stroke, migraine, and Parkinson's patients in the past. And we read about that. I mean, that's the DARPA laser flashes of light to the brain stuff. And then, of course, with nerve stimulation, another non-invasive technique that involves delivering electrical impulses to the median nerve of the upper limb. And we talked about some of that direct elect RX program from DARPA that uses zip-zap sounds and electrical impulses to control different aspects of the body and repair things. So this is pretty far out there. It's interesting that they're doing it in a lab or in a treatment facility in India, but they got the approval of the National Institute of Health, and they're going to be taking Americans over there to try some of this Frankenstein science on people who are clinically dead. To undertake such a complex initiative, we are combining biologic regenerative medicine tools with other existing medical devices typically used for stimulation of the central nervous system in patients with other severe disorders of consciousness. That's the first I've heard it called that, disorders of consciousness. The researchers will test whether this combination of treatments can help kickstart the cell regeneration process in their 20 recruits, with Napton comparing how a salamander and newt cells are able to automatically regenerate new tissues and muscle cells to regrow entire limbs. That's twice now that they have mentioned in 2 different stories salamanders being able to regenerate. To be clear, brain dead or clinically dead patients are still being kept alive, but only through the work of life support machines, which means that they cannot breathe or circulate blood on their own, and their brains have completely shut down all functioning. Many do retain certain vital functions, though, such as waste processing, digesting nutrients, healing wounds, growing and maturing, and some can even fight off infections and gestate a baby. Oh, how would they even know that? I don't want to know. But if we can figure out how to get their brains working again, there is hope that we could regain some semblance of life. But let's not get too ahead of ourselves here because it's a long road ahead of us. And if this trial sees any positive results for now, the researchers are only taking one step at a time. This is a long-term vision to see the full coverage of your patients as a possibility, although it is not the first focus of the study, but it is a bridge. And it will gain us unique insights into the state of the human brain death. Ding, ding, brain project, guys. And we will have important connections to future therapeutic development for other severe disorders of consciousness, such as coma and vegetative and minimally conscious states, as well as a range of degenerative conditions, including Alzheimer's and Parkinson's. Again, there's that Parkinson's disease. Now, guys, tell me if this is not frightening, but imagine what is going to happen when they bring these people back and they're not quite what they were before. I mean, if anyone ever read Pet Sematary, talk about horrifying. So here's even more horrifying. Google, we have Sony, we have Samsung patented the contact lens camera. We have Sony, who now has patented the contact lens video recorder and playback. And Google, on the 29th of April, it was a couple days ago, patents a device to inject into your eyeball. Guys, if you remember, I told you, do not let them get near your eyeball. Direct connect to the brain via the optic nerve. Well, forget laser surgery. If Google has any say in it, we will soon be injecting devices into our eyeballs to help improve our vision. Ding, ding. All right, guys. Well, make sure you stick around because Lonnie Clock is live up next. And it is Wednesday, so lots of live radio. We have Josh live at 6 p.m. Eastern. We have the boys from New York live at 8. And Liam Schuff, brand new show at 9 p.m. and live Anti-Media Radio with Nick and DB at 11. All right, guys, make sure you have an awesome Wednesday, and I'll catch up with you tomorrow. Take care.